Okay, I got rid of that BMS, everything on this. That the whole other 12-volt battery got separated the two. The BMS isn't there, but the wires are still there, so I can hook it up again after. All I have is four 25 amp hour lithium iron phosphate cells with a shunt and the meter. And you can see there's a voltage of that same cell I was monitoring the last time, and it's the same voltage as what I started the last time. And the only transferring I did was with the light bulbs, which was from 92 volts. Like I might have did 2 transfers. I have it all on video. Can't remember. I might have did one with the transformer and one with the light bulb. But when I did the light bulb from 92 volts, I know that one was from 92 volts. Pretty sure it was. You can do the math. 13.1 volts is what this battery's at right now. And it's always been that. So 13.1 volts. You subtract 13.1 from 92, and you have your current that's going through. Well, the rest of that power is going through the light bulb. It's some like 7 or 8 watts was going through the light bulb. And the battery was getting 1.4 or something. 1.3. I can't remember what it was. And that's what returned the voltage back to where it was. And this battery's been resting for 4 or 5 days. I'll have to go back and look and see when I stopped using this coil last time, because that's how long the battery's been resting for. I've not touched it. Only thing I've done is remove that other part and made new end pieces. That's it. Put it back together. Never touched any of the terminals for discharging purposes. So yeah, and I wasted more than 3 times the power into that light bulb than what I transferred back into the battery. And it's still the same. But I'm about to start again here anyway. I'm about to turn it on and go from there. I've got it already. I just did a quick check to see what it's going to be pulling for current. It's 488 milliamps right off the bat here. I have 2 transistors parallel together, so that should help with the efficiency. Keep the heat down for a bit. Voltage has to rise quite a bit though. It's lower than what I started with before, so it's not ideal. Let's turn it on now. I pinned it. It's gonna suck it down pretty good, but see what it can do, I guess. I'll keep an eye on the temperature. I wonder how much this is here. Just for curiosity's sake, put this here. That light's already on. It's a pretty big magnetic field. Yeah, they're both pretty bright. Doesn't seem to affect the input at all. A little bit when you get it right close. But I think that's because I was touching this wire here. That's what's doing that. Hold on, it's making it right here. Doesn't hurt it though. Just like all of a sudden changes the tone. Just like hitting a switch, that little tiny movement. frequency's slow right now, really slow. It's a pure square wave almost because of the LEDs. See what happens when the tone changes. It's not changing now. Huh. Not sure. Just puts it out of resonance. I won't. Always said if you have any extra power in the ear, it's being wasted. And of course, you're going to be able to couple this magnetically. Okay, so I stopped at about, I don't know, 75 volts or so, and I took off the FR107, replaced it with two FR207s parallel together, just to try to eliminate any bottlenecks in the circuit. Just to try to make it as efficient as possible when it comes to diodes and stuff like that. Here's the current. Yellow is the current. See, it's starting to come down quite a bit here now. What you'll see is this wave here is going to start to stretch out. And let me just stretch it out a bit here. You'll see it. You can see how this is all below the center line. So that's returning to the battery. I'm not sure what that measures. It's 132 milliamps. 124. That little pulse is 134. It has a pretty steady, we're in the center here. Okay, it's been a while going now, so I'm probably just going to leave this overnight, and probably till tomorrow night too, because I go to work in the morning, so as far as I know, I have to work. So you can see it's trying to hit 8.4. Started this at 3.286. So it's just kind of going to its resting. It's pretty much zero. Still charging. By tomorrow night, it'll probably be 92 volts or so. 91, maybe. I don't know. I'm not sure. Highest I've ever let it get with this 7 rows of caps here, 42 caps, was 90 volts. 90.5 or something like that. I'd have to look back at the footage, but and then it hit 92.5 or something when I had all the caps hooked up with this circuit and coil. So I'll just leave it run, and both those times it was 3.284 when it was charged up. So I don't know, it might level out at like 3.284 and then come back down 1 point or so. It's kind of what I expect it to do. Just because I'm going to leave it a bit longer than I probably, like, I should be transferring it now. But I'm just going to leave it because I like to leave it rest before I charge up again. For like 3 hours or so, 3 or 4 hours, so I can get a good reading on the voltage. like a resting battery voltage and leave the caps rest again. Because gotta remember I started this test with the voltage a lot lower than I should have with this coil. This coil's not really made to be brought that low. So I was out of resonance and it was pulling like half an amp for quite a long time. It was 55 volts. And I only really want to bring it down about 20 volts. So from 90, I'd like to bring it down to about 70. And that'll give me the best efficiencies at the transfer and power generating. As far as I know, anyways, I haven't done enough testing. I need to do more testing, like bringing it down lower voltages. Because I. Okay, guys, this is about 9 hours since my last update here. Can you see that? 3283. Put it like that. Hopefully you can see that a little better. I think so. 3283. Okay, I got this too. I'm gonna show this time too. I'm gonna put the volts of the cap bank right here, the amps, and then it'll be the watts, because even though the volts in the cap bank, though you have to keep in mind it's gonna vary between the bulb and the battery, right? The battery's always gonna be at 13.1. It's not gonna change enough to make that change. See right here, 13.1 volts. Top left. So I'll be able to measure the current through there too, because it's accurate with a steady deep DC. But I'm going to transfer the power through the bulb, 25 watt microwave oven bulb. And then I'll give the readings and the watts. I'll probably bring it down to 68 volts. Even though I started at 55. So it should be a pretty good demo. Most of the power is going to get burnt off in the light bulb. Almost all of it, actually. And I'm not going to be bringing it down to as low as I started with. It was 55 point some when I started. I can bring it down to 70 should be enough, and it'll be easier in the next charge. Keep in mind I'm powering the meter too right now. So I'm going to start right now. I'll do some readings here. Probably do one at 90. So I'll need to have the current reading, and I'll be able to do a watt conversion. So it's 120 milliamps pulling right now. There's 9.24 watts being burnt off in that bulb right now. And there's 1.58 in the light bulb. I just rounded it to the nearest. See, I started with 90 volts, and then you do the subtraction of what each is getting here. That's divided between the two at 120 milliamps, and there's your wattage for each. So the battery's getting 1.56. I'll do another reading at 85. I just have to wait till I can get the milliamp reading at 85 volts. There's not much power that's getting back to the battery. Most of it's right here. It's pretty hot. I started charging that cap, and the cap was at 55 volts. This battery voltage was 3.286. Now I'm going to bring it down to 68 volts because it will rebound back up to 70 or so. Maybe a little higher after I leave it rest. If this gets up to 3.30, 3.290, that it'll easily rest at where we were when we started. Meanwhile, we're burning off way more power in the light bulb. So now we're at 100 and call it 115 milliamps. Bulb has 8.2 watts in it. 8.28. And the light bulb has 1.495. So the ratio is like lots. The difference. That's my wind turbine charge controller. It was telling me what's going on, but it's not on very often. Not when the sun's out. I only turn it on when I need it. So I'll do another one at 80 volts. And then I'll just do the last one at 75. So you have a pretty good idea after that. See the last numbers here. That's battery, that's bulb, battery and bulb, 90 volts, 85 volts. You can see the big difference in power, where it's going. There's way more going to the bulb than what's being returned to the battery. This is why I do it like this, so it's very easily to see how much extra there really is. And since I balanced those caps out, it's been even better. They're not hitting the protection board voltage anymore. Everything's equal. Well, equaler than they were anyway. And 12 milliamps now. .5 in the bulb. .456 in the battery. I already know if it hits 3.29 for any decent amount of time, it's gonna rest pretty much right where we started. So that's that right now. And at the end, I'll tally it all up and Well, up to 75 volts because I'm not even going to take a reading at 7. Well, I can. I'll just do a couple more lines here. Might as well do it up to 70 anyway. You know, if I was transferring all this energy back to the battery, like putting it all back in there, that battery would be a lot higher than when we started. Right now, we're just transferring enough to keep maintain its voltage. About with the 26-volt battery, I was able to get a little bit extra into the battery. This one too, though, I think it's gaining a little bit with the battery. Yeah, it's already at 2.9. I've got the other test going with LiPo batteries instead of caps with that other coil. So it's 107 milliamps. $6.634. 1.391 in the battery. milliamps. .814 in light bulb. .326 in the battery. So in this lowest reading, this is the 5.814 watts divided by 1.326 is 4.38 times more power going in. In the light bulb. So that'd be good enough. Don't forget I'm powering the meter also. So now I'll do the top one up here. The first one. So right here, I just kind of crudely wrote all this down. Well, here's all the results anyway. You know, each one of these is, this is 90 volts, 85, 80, you know, so on. But right here, you do the math, just take this number and divide it by this one, and you'll have how many more times watts, you know. At this point here, there's almost 6 times more power going to the light bulb. And at the lowest part here at 70 volts, there was 4.38 times more going into the bulb than there was going to the battery. So this is a pretty obvious test. You know, the results speak for themselves. This isn't some gimmick that I'm pulling off here. This is real. The numbers are there. And you know, one of these times here when I have more time, I'm going to set up a live stream, which will run for like a week of me doing this. I won't be here, but the live stream will be going as long as the Wi-Fi doesn't cut out. It'll be going. This is the 39 ohm coil at 24 gauge, and there's 3.3 ohms of 19 gauge. And it's running with 13.1 volts. So I'll leave this recover for a bit. And I started at 55 volts. You go back, I'll post this whole video of the charge and discharge all in one. You'll be able to go look at the beginning. It was 55 volts, and this was pulling over half an amp on this gauge for me to bring it back up to where the coil got back in the resonance. I could have left it go longer too. But I'm going to leave it rest here now for 3 hours. And it's probably going to settle right back where we were when we started. This will recover probably to just above 70 or so. I'm not sure. It's been recovering. It's a little more stable since I balanced out the caps where there's none of them that were hitting the balance board. They're all a lot more equal. But yeah, I'll be back in 3 hours. So here's an hour later. Just trying to. It's about right where we started. And don't forget that this was at 55 volts when I started too. So, and it's just rebounding here now to that. But if I can be back in a couple more hours, I'll be back and take another reading. Hey guys, it's been 2 hours later. He's just bouncing off a 8.6 and 8.5. It's almost right back to where we started, and this should have been brought down to 53 in order for it to rest at 55 and change. And we still pretty much returned it right back to where we were, while still burning off a minimum of 4.38 more in the bulb than what went into the battery. The numbers are here for that discharge transfer. Started off at 5.92 times more, ended with 4.38 at 70 volts. And that would have went down obviously as the voltage would have dropped if it would have kept going. But things are pretty close here to being leveling out. So that's it for that. I'm going to start charging things back up again.